Over roughly 3 weeks this summer, AI systems reportedly resolved more open math problems than humans managed in the previous decade. One conjecture that stood for 30 years fell to just 4 prompts, totaling 58 words. The reaction from the academic community was immediate. At the International Congress of Mathematicians, Fields medalist Terence Tao delivered a lecture framing this moment as a crisis in the foundations of mathematical practice. This exponential capability is bleeding into creative judgment as well. A system called Sage can now turn scripts into storyboards for short-form drama, matching the scores of human directors on professional rubrics while cutting production time by 83%. Digital intelligence has achieved an illusion of weightless, infinite scale. But that illusion is about to violently crash into the physical reality of the hardware required to run it. Every advanced algorithm eventually meets a hard limit in the physical world: the supply of DRAM memory chips that allow a computer to hold information while it works. A global shortage reversed 20 years of falling costs. Memory prices surged 500% in 12 months. Now, hyperscalers are hoarding future supply, placing massive advanced deposits on nearly all DRAM production capacity through 2027. This chart compares the cost per kilogram of industrial materials against precious metals. At current market rates, high-performance memory chips now cost more than half as much as solid gold. Progress now depends on chip supply rather than just model design. The ceiling on AI's growth is the unforgiving physical scarcity of silicon. Resource starvation is fracturing the AI ecosystem. As the hardware bottleneck tightens, companies are scrambling to lock down their territories and build defensive walls. Google recently moved certain Pixel phones' source code behind a manual request form and a private drive link, forcing developers to wait weeks for code that was previously available for instant public download. Open source advocates argue this manual gatekeeping violates the GPL v2 that governs the Linux kernel at the heart of the Android operating system. At the same time, OpenAI is turning data handling into a competitive weapon. Their new zero data retention policy for businesses deletes prompts and answers the moment they are processed, pitching absolute privacy as a way to lure users away from rivals. These moves represent a strategic shift. Physical limits have turned privacy settings and source code into ruthless competitive moats. Survival in a resource-constrained market requires squeezing more performance out of less hardware. The industry is pivoting from brute force scaling to extreme efficiency. New compression techniques allow massive AI models to be shrunk down to run offline on cheap, credit card-sized hardware like the Raspberry Pi. These compressed models retain 97% original accuracy, proving capable AI doesn't always require a massive data center footprint. This drive for efficiency is even changing how we handle safety. Instead of asking a model to grade its own answers, developers are reading the model's internal signals to predict trustworthiness, a method that is both cheaper and more accurate. In a world of rationed memory, the ultimate technological advantage belongs to the engineers who waste the least space. The resource crunch is also providing a reality check on the hype of the AI scientist. New benchmarks are testing whether these systems can actually innovate under constrained conditions. This visualization maps the designs of AI agents tasked with inventing new research methods. Without human guidance, nearly 97% of their designs fall inside existing human approaches, and almost half are exact copies of human work. While AI struggles to invent, open-weight models provide a critical defense against monopolies trying to exploit the hardware shortage through high prices. We saw this dynamic recently when DeepSeek released its full V4 Pro model, then immediately raised its own hosting prices by up to 5 times. This line chart shows DeepSeek's price hike in red. Because the model uses a permissive MIT license, rival providers instantly hosted the exact same model to undercut the increase, crushing the price back down to the original baseline. The dream of infinite AI has met the heavy, expensive reality of silicon. The future belongs to those who master the physics of the bottleneck, not just the code.